Good morning, children. Today we are going to discuss about another important topic, digestion in the buccal cavity. What's our topic name? Digestion in the buccal cavity. So we discussed about the digestion parts, buccal cavity, what you call the parts of the digestive system, mouth, esophagus, types of teeth, like that different concepts we discussed. So now we are going to liver, okay, salivary glands, pancreas, like that we discussed. Now from this lesson, from this concept, what we will learn is what is called the digestion in the buccal cavity. What is the concept name is digestion in the buccal cavity. Digestion in the buccal cavity. Digestion in the buccal cavity. Okay, children. There will be what is called when you hear this, when you see the smell, sight and taste as well as mechanical stimulation, reflex action will be takes place. You know very well, saliva, salivary amylase, mucus. Okay, digest the food. Mucus helpful for the what you call mastication, and also swallowing. Like the different things will be there. At last bolus will form. So bolus will be there. Like that we discussed, right? Now we are going to discuss about the salivary amylase function, what converts the starch to maltose. So then after some enzyme reactions and mastication and all these things, what you will see, there will be the formation of the bolus. What we will see, the formation of the bolus. You see, the bolus means chewed food, okay, or masticated food. That bolus reaches the which one? Pharynx. Bolus reaches the which one? The pharynx. Bolus reaches the pharynx. Very, very important. Then the bolus, okay, about 30% of polysaccharides starch is hydrolyzed by how much percentage? 30% of the starch. 30% of the starch hydrolyzed by salivary amylase. Okay. Okay, very important. Enzyme disaccharides. Okay, the bolus is passed into the now. So disaccharated. Okay, maltose and bolus form that reaches the pharynx. Pharynx to which part? Next, the pharynx to the bolus will go to the very important tube-like structure, the foot pipe. What is the foot pipe? Pharynx to it will go to esophagus. It will go to esophagus. Okay, children. So esophagus by swallowing. So what you call that process? Swallowing is called what you called deglutination. What you call that process? Deglutination. That swallowing process is called deglutination. Then esophagus too, through the peristalsis, peristaltic movements. Through the peristaltic movements, the food will reaches the which part? In the stomach region. So salivary amylase digests the starch and converts the maltose, then forms the bolus. 30% of the starch will be converted into maltose. That bolus will be converted or moves to the pharynx. Pharynx to esophagus. That swallowing process called deglutination. Esophagus performs the which kind of movements? Peristalsis. So the gastroesophageal sphincter. What do you call that is? The gastroesophageal sphincter is there. That gastroesophageal sphincter, where it present? When the esophagus open into the which one? Stomach. That particular area, very important bit. What do you call that bit name is? The gastroesophageal sphincter. It controls the passage of food into which one? It controls the passage food into which one? Stomach. Okay. So that is the most important part. Okay. First we are eating bolus. Bolus, where it will be go? Bolus will be formed. The chewed, masticated food is called bolus. That bolus reaches the pharynx. Pharynx to that food we will go reaches the esophagus. Esophagus. The swallowing is called deglutination. In the esophagus, peristaltic movements. What do you call the contraction? Relaxation. Such kind of movements will be there. Peristaltic movements. Through the peristalsis, the food reaches the stomach. Where the esophagus enter into the stomach, which part? There will be fundic, cardiac. Okay, 5 aortic parts are there or not? So where the first starting part, so cardiac part, okay, there will be, what will be there? The food will be enter into the, which one? The esophagus will enter into the stomach. There itself one sphincter is there. What is that sphincter? The sphincter name is very very important. Cardiac sphincter or also gastroesophageal sphincter. What do you call that sphincter name? Cardiac sphincter or gastroesophageal sphincter. It controls the passage of food into the stomach. Now come to the next concept. What is the next concept? Digestion in the stomach. What is the next concept? Digestion in the stomach. Digestion in the stomach. So what you know about the stomach? Come on, tell what is stomach? Stomach is the J-shaped bag-like structure, right? What is the stomach? Stomach is a J-shaped bag-like structure. So in the stomach, how many hours it will be? Our food will be stored. So food remains in the stomach how many hours? Very important bit, 4 to 5 hours. So 4 to 5 hours the what you call food will be stored. Then what will happen? The rhythmic peristaltic movement churns and mix the food with the gastric juice. So rhythmic and peristaltic movements mix or churns the food and mix with the gastric juice and make it a creamy liquid called, what you call creamy liquid? Come on, that creamy liquid only called, very very important, that is called chyme will be formed. So what will happen? The food through the esophagus or the bolus through esophagus which enter into the what you called the stomach. Then after in the stomach mixing will be takes place. The food mixing will be takes place. Okay, with gastric juice secretions and everything. At last what will happen? The creamy liquid what you call creamy liquid food formed. That creamy liquid only called what you called chyme. That is called chyme. So don't confuse between the bolus. Bolus is different, chyme is different. Bolus is masticated food. Chyme is after churning and mixing in the stomach with the gastric juice, a creamy what you called liquid will be formed. That is called chyme. That is called chyme. So that is the most important chyme formation we will see in that particular area. Okay, and the gastric secretion is partly controlled by autonomic reflexes. So the gastric juice secretion is there or not? So who will control the gastric juice? Suppose you are feeling food, means your gastric juice will be released, or not there means gastric juice will not release. If you didn't take the food, gastric juice will not release. Then who will control that secretion of the gastric juice in the stomach? There will be one particular system is there. So the secretion of gastric juices, okay, under control of one reflex reactions. Those reflex reactions are called autonomic reflexes. What do you call those reflexes? Autonomic reflexes. The reflexes which can helpful for the regulation of secretion of gastric juice in the stomach. Those reflexes are very important. That's why they are called selfly they will be autonomic reflexes. Autonomic reflexes. Next, the stomach secreting the gastric juice or not? So that is the most important secretion for the digestion of the food. So gastric juice begins when the food is in the mouth. When the first mouth in the mouth itself, when you keep the food, then the secretion of gastric juice will be takes place. So very important point. When the food you keep in the mouth, when you keep the food in the mouth, then that time itself what will happen? The secretion of gastric juice will be start. Okay, this point you should have to remember. Okay, next, another important thing what we have to remember is gastric juice contains what? What is the gastric juice materials? HCl. What is there in the gastric juice? Hydrochloric acid. What is HCl? Hydrochloric acid is there. That hydrochloric acid very useful for the digestion of the food. Why? Because the HCl activates the HCl activates the which one? The enzymes. HCl activates the enzymes. So pro-enzymes will be converted into active enzymes. Pro-enzymes converted into active enzymes. So the HCl is a very important and plays a very vital role for the activation of the digestion. HCl digests the food. HCl activates the which one? The enzymes. For example, you see here I am telling HCl is there. HCl proenzymes are means inactive. Pepsinogen. So pepsinogen is activated by HCl. So pepsinogen is activated, proenzyme inactive form converted into active form pepsin. So this pepsin converts the proteins. This pepsin converts the proteins into peptones. The pepsin converts the proteins into peptones. That is called peptides. Proteins converted to peptones are peptides. This is another important point. Next, HCl is the what you call protein. Pepsin digests the proteins into peptones. So pepsinogen is activated by HCl and converted to pepsin. This pepsin converts the proteins to peptones or peptides. Very important form structure. Next, HCl is the very important acidic medium which is optimum. Optimum means what? Very good atmosphere, very good in that particular area that pepsin enzyme will be activate. Okay, so HCl is what you called optimum for the pepsin. Now what are the functions of HCl? Come on, tell what are the functions of HCl. HCl kills the bacteria. HCl kills the bacteria and other harmful microorganisms and also avoids the putrefaction. Any unwanted decomposition will be there. That process also, putrefaction also controlled by which one? The HCl. Very, very important. Next, the mucus and bicarbonates present in the gastric juice plays an important role in the lubrication and protection of mucosal epithelium. So, mucus is there and bicarbonates are present in the gastric juice, right? What are there? Come on, tell the what is there in the gastric juice? Mucus, bicarbonates present in the gastric juice play an important role in the lubrication and protection of mucosal epithelium from the eroding nature of the highly acidic HCl. See, acid. HCl is the acid. It will be what you called causes the what you called eroding nature. So then who will protect our intestinal mucosa and everything? So that gastric juice is there or not? That gastric juice contains the mucus and bicarbonates. This mucus and bicarbonates present in the gastric juice plays an important role in the lubrication and the protection. Mucus and bicarbonates present in the gastric juice plays an important role in lubrication and protection of the mucosal epithelium from the eroding nature of the highly acidic HCl. Highly acidic HCl. Another proteolytic enzymes. Another proteolytic enzyme, gastrin. Gastrin, what you called in another proteolytic enzymes are there in the what you called very, very important. Another proteolytic enzyme found in the gastric juice of infants. Gastric juice of infants. Where another proteolytic enzymes present in the which one? Gastric juice of infants. What you call? Gastric juice of infants. This is important. Gastric juice of infants. Okay, another proteolytic enzyme present in the gastric juice of infants, that is called renin. What is called? Renin. Renin. So renin. Renin. What is this renin will do? It will be act on milk protein. What renin will do? In the small babies will drink the milk, right? In that milk, the renin is there. That renin, in that milk, casein protein is there. So this renin act on the casein and digest very, very important caseinogen to casein. So it converts the caseinogen to milk protein caseinogen to casein in the presence of calcium enzyme. So what happened? Once again, so another proteolytic enzyme in the gastric juice of infants, small babies. One enzyme is there, that is called renin. Converts the caseinogen to casein in the presence of calcium plus and renin. Okay, so caseinogen, casein, very important. Okay, Like that, another important functions are there. Another HCl is very useful, and also gastric juices are there. These are very useful for the what you call conversion of the complex materials to simple materials. Next, come to saliva. Generally, saliva pH is acidic, 5.4 pH, but it will be converted to 7.4. How? Because of which one? Bicarbonate. So, another important function of the bicarbonates converts the saliva pH from acidic to alkaline. Acidic to alkaline. That is also important. Next, digestion in the small intestine. Next concept what? Digestion in the small intestine. So, bile and pancreatic juice. Bile and pancreatic juice, which are very useful. So now next concept what? Digestion in the small intestine. Bile, pancreatic juice and intestinal juice directly release into the small intestine. The small intestine is a very important 99 point, means maximum amount of digestion and absorption will be takes place. Maximum amount of digestion and absorption will be takes place in the small intestine. So digestion in the small intestine. So bile is there or not? From bile, where it is coming? The bile is coming from where? The liver. Pancreatic juice coming from pancreas. Intestinal juice means succus entericus. In the intestine itself, the secretion will be there. So these all very useful in the digestion and digestion of the food in the which one? The small intestine. Okay, children. Once again, should listen very carefully. We are discussing the concept is digestion in the buccal cavity. So 30% of the starch converted into what? The maltose disaccharides in the buccal cavity. So after that, maltose and chewing and masticated food is called bolus. That bolus reaches the pharynx, pharynx to esophagus. That's called swallowing, deglutination. So in the esophagus, peristalsis will be takes place. In the esophagus, what will be takes place? Peristaltic movements. What you call? Peristaltic movements will be takes place. The peristaltic movements are very useful for the movement of the food from from upper to lower parts. Okay. So what will happen? You see, the stomach. When the esophagus reaches the stomach, what will be there? One sphincter will be there. What is that sphincter? Gastroesophageal sphincter. So movement of the passage of the what you call food into stomach regulated by which one? Gastroesophageal sphincter is there. It controls the food passage into the stomach. Next come to next concept, digestion in the stomach. In the stomach, the food will be stored 4 to 5 hours. There what will happen? Then the stomach walls shows the rhythmic and peristaltic movements. Then churns and mixes the food with the gastric juice and makes the what you call and makes the that food into a creamy liquid called chyme. What you call that is chyme. So then who will regulate the gastric juices? Who will regulate the gastric juices? The gastric juices regulated by autonomic reflexes. What are the autonomic reflexes? You know very well, autonomic nervous system, sympathetic, parasympathetic, like that. Autonomic reflexes is managed by gastric juice. So when you eat food, gastric juice secretion by autonomic. When you don't eat, no secretion of gastric juice. Like that, autonomic reflexes regulates the gastric juice. Now, gastric juice contains very important structure or very important compound. That compound is you know very well, acid HCl. So very important. This HCl converts first HCl main function is converts inactivated enzyme to active, proenzyme to enzymes. Okay, pepsinogen is a proenzyme. Active enzyme is pepsin. So pepsinogen converts into pepsin by the help of HCl. Pepsinogen convert into pepsin by the help of HCl. Then the pepsin converts the proteins into peptides. Pepsin converts the proteins into peptides. So next, HCl is a very important acidic medium. So that is optimum. So HCl is the acidic medium that is optimum for which one? Pepsin. Optimum for pepsin. This is important. Kills the bacteria. Okay, HCl kills the bacteria and other harmful, what you call other harmful microorganisms also kills by the HCl and avoids the unwanted putrefaction process in the stomach region. Very important. HCl is very useful for the activation of energy. Next, some other components are there in the bicarb in the what you called gastric juice. What are the other compounds? Mucus and bicarbonates also there. This mucus bicarbonates present in the gastric juice plays an important role in the mucus bicarbonate present in the gastric juice plays an important role in lubrication and protection of mucosal epithelium from the eroding nature. Otherwise, ulcers will come. Too much HCl, ulcers. So, eroding nature of the highly acidic HCl. So, from that, mucus and bicarbonates. Why? The bicarbonates, what they will do? Converts the pH from 5.4 to 7.4 in saliva. Like that, reduces the or creates the alkaline nature to the acids. Next, another proteolytic enzyme in the gastric juice of infants. What is that one? Renin. What is that? Gastric juice of infants, that is called renin. Act on milk protein caseinogen, converts the casein. So when the age is increasing, that renin will be disappear or will not be shown by the gastric juice. Now, digestion in the small intestine. The small intestine digestion very simple. Why? The bile and the pancreatic, all intestinal juices, bile from liver, pancreatic juice from pancreas, intestinal, there itself some secretion, intestine succus centricus, all will be enter into the will be act on the in the small intestine food, and 99% digestion and absorption will be takes place in the small intestine. Okay, children.